We've spent the past few years discussing large language models, the huge AI models that power a lot of generative AI tools and that have come to dominate the headlines. But small language models are also possible and rapidly growing in popularity.
So what benefits do these tiny AI models offer, and how much use will they get in the coming months and years? How also do they differ from other lightweight, so-called low latency models? You're listening to the IT Pro podcast.
Hi, I'm Jane McCallion.
And I'm Rory Bathgate.
And today we're taking a look at some of the smallest AI models on the market and asking, what are they for and could they be the future of the technology? So Rory, you admittedly have your finger on the AI pulse a little bit more than I do. What are we talking about when we talk about small language models?
So on paper, a small language model it's typically also a generative AI model. It will use transformer architecture, which is what most of the large language models use. But it's specifically been created to be quite lightweight, have far fewer parameters than you would find in a large language model. And all of this adds up to a complete model that you can run on lower grade hardware, and maybe you can run it more easily at the edge if that's a specific use case that you're looking for. Typically, a small language model will be slightly less powerful than large language models. It might be that it's text only, or that if it has any kind of multimodal capacity, it's significantly reduced in its overall sophistication compared to large language models. So it's kind of a swings and roundabout situation where you might more easily be able to run it where you want to, but you have to balance that against the reduced power.
So is it quite a niche application then, really?
So they are increasing in use. So small language models are very good, as I said, at running at the edge. And this might look like running it on a smartphone. It could look like running a dedicated AI model on a laptop. But also, if you're a company that wants to run AI where your data is, say in a factory environment, small language models can become quite useful for very specific purposes. So if you had a small language model that was tiny enough that you could run it, say, on factory hardware, and all it did was process visual input with very low latency, and because it was running right there in the factory environment itself, that would be quite niche. But equally, some of the biggest developers in AI, we'll talk about this in a minute, are releasing open small language models. So it's clear that there is demand.
So since 2022, really, when we've been speaking about AI, when people have been speaking about AI, what they've meant is generative AI. Even LLMs, it's always spoken about now in the context of generative AI. Are these small language models generative AI, or are they just, say, a computer vision application? Not to kind of diss computer vision, because it is quite impressive, but it's not generative AI.
Yeah, so they are generative AI. The example I gave would be of some sort of multimodal capacity within a small language model. A lot of the small language models that we see today, so for example, Google has released Gemma 3, which is an open small language model. Microsoft has released Phi 3. We'll talk about some others in a minute, are specifically for handling text and calculations. So take Phi 3. Microsoft gave the example of using them for organizations with very limited resources, using them for very specific needs at the edge. So for example, if you wanted to put small language models on smartphones or in a vehicle, they could, say, very quickly answer user prompts without needing to send any data to the cloud or even have to stop and process the requests. So you would need to fine tune them for what you expect them to be used for. So say in the example of the vehicle, the small language model would need to be very reliable at producing, say, route maps or answering questions based on likely questions that you would ask a small language model in a vehicle. This is something that you hear of more and more, actually, is AI being used at the edge in things like cars, in things like smartphones. And it's still kind of a burgeoning technology. And we'll also get onto that in a minute to talk about kind of reality check on how easy it is to run these things at the edge. But they are getting more and more sophisticated.
Yeah. So, I mean, it does feel a bit like a continuation of the good old edge computing conversation that was spawned with cloud, that, yes, instead of it all being about self-driving cars, say, and making sure you don't crash into stuff, knowing and be able to process inputs in the car, it's more like, I've just seen a diversion sign that must be new. I can't go down wherever. Where can I turn to get to my destination? And then have it reroute straight away. So that's kind of interesting that it does build on all these older trends like mobile data, so 5G, 6G, whenever that comes around, and yes, edge and multi-sensor input and all that kind of thing.
Yeah, absolutely. And it's also worth mentioning that small language models aren't just for running them on premise or on a specific device. So a number of small language models, I mean, you could run any of these small language models in your data center. Things like Gemma 3 and Phi 3, you can download through Hugging Face for your business and run them on whatever hardware you have to hand. But equally, some companies like OpenAI offer very lightweight, small models. And there is some contention over, as there is with open source, we talk about open models rather than open source models sometimes, depending on the limitations of where you can download them. Small language models, as quite a broad category, includes both open and proprietary models. So, for example, OpenAI just announced GPT 4.1 Mini and Nano, which are incredibly lightweight models that are, compared to its other models, very cheap to inference. So very cheap to both give it input and receive output tokens from the models. They are only accessible in the cloud, as with all of OpenAI's models, but they offer a pretty sizable increase in speed. So OpenAI says that with Nano, between a prompt and a response, you can expect around 5 seconds of processing time. And that might not sound super impressive, but that applies with any prompt up to 128,000 tokens. So you could give it a serious amount of information and have it very rapidly respond with either a summary or picking out details from within that information. The trade-off, as ever, is the response you get might be less detailed than if you were willing to wait. So it really should only be used for those use cases that require that fast response time.
Fair enough. I'm going to nip back to what you just said about being able to download these and put them in your data center, whatever. So if I, for example, took Mistral 7B and downloaded it and shoved it in my data center, what would be the benefit of doing that rather than just using a large language model in the cloud? Why would I do that?
For a lot of companies, it comes down to control over their own data. There's a burgeoning discussion around sovereign data capacity right now, sovereign cloud. Some businesses, even if they, it's not a matter of trust so much as it is a matter of oversight. You could trust your cloud provider, but ultimately, if you're handling really sensitive information, say you have an air-gapped system and you want to use AI there, it might be that you reckon your best bet there is to get a model that is very, very good at the specific use case you want and to put it in your own environment. And then you have total oversight, total control over all of that. And you never have to pass your data, your essentially very sensitive data, into the cloud and risk it leaking.
And they can still learn like an LLM normally would from the data that's input into them or from the data available.
Yeah, so this would depend on the deployment. There is a process known as distillation, which I'll talk about in a second, but that would require some training architecture and training infrastructure that would need to be used. So I guess one of the benefits of relying on a cloud provider for your AI is, yes, you do receive updates, the models continue to learn over time. Whereas if you are choosing to go not off grid, but downloading a model and taking it and working on it in your own environment, then you ultimately are responsible for ensuring that model becomes more sophisticated over time. It's not an inherent trait.
It's homeschooling versus sending them to high school.
If you like.
So what is distillation then?
Most people will have come across this term, or at least this term was heavily covered around January with DeepSeek. We talked about DeepSeek around then, the big upset that it caused in the market. Distillation, in short, is taking a small model, typically an open source, quite lightweight, small language model, and training it based on outputs from a much larger model. So DeepSeek R1 is a very large, sophisticated model. What DeepSeek did in January is it took models from Qwen by Alibaba and also Llama by Meta and trained them on R1. So if you have a distilled DeepSeek Llama model, what that is, it's a very small language model that has been trained on the outputs from DeepSeek R1. So it's a shortcut for making those smaller language models that might inherently be less sophisticated and improving the sophistication of their outputs by teaching them the best outputs as instructed by a much larger language model.
So continuing my education analogy then, DeepSeek R1 is the professor and the llama trained on it is the student being trained to give the correct or best answers.
Yeah, absolutely. It's skipping out that raw data training stage, just cutting straight to the model that already knows the best things to say, and then passing that information on. It might not be viable over time. It's quite a new approach, and as with everything, there'll be some data degradation. So my gut feeling would be that, for example, taking a model it's self-learned through distillation and trying to teach other models based on that, you might not get the results that you're looking for. But it certainly is a way of making small language models better at specific things. And that's something else to point out here. There are 6 distilled DeepSeek models, and each one of them is good at a specific thing over the others. So you lose some of that general capacity that large language models have, and you end up having to pick the right tool for the job in each different scenario.
Now, this sounds like I'm, kind of not a generative AI super fangirl or anything. I know some people are really into it. That's not me. But when we're talking about these kind of niche models, the DeepSeek models where you have to choose the right tool for the job, this feels like a step back in terms of the evolution of AI. This is what we had before. You have very advanced AI that is really good at doing one specific thing. And it sounds like that's where we're going to end up. You also mentioned data degradation, and that's a problem that I understood existed as well, that when AIs end up being trained on AI outputs over time, dramatically, people will say they go mad, but the outputs start being less and less good.
Yeah, I think what you've highlighted there is that this is it's not necessarily the best route for every business. It's not necessarily the best thing to do for every situation. I kind of hinted at this earlier. It's worth pointing out here that this is also not something you can download and run on your laptop.
What?
Gemma 3, for example, which is Google's most sophisticated small language model, they were very proud about saying that this can be run on a single GPU or a single TPU, which is a tensor processing unit, which Google creates. But they mean an NVIDIA H100 GPU, which costs between $25,000 and $40,000. These are data center GPUs they're talking about. Yeah,
absolute
you're not heading down to the secondhand electronics store and picking up a used GPU here to run these things. So it remains primarily, first of all, something for enterprises, and it's also not necessarily something that you can run on every single device. It will vary. As far as the complexity of it goes, this is in some ways the pros and cons of the open source ecosystem. There are so many different open source AI models already. One of the, again, benefits and drawbacks of making these things open source is that people will create their own spin-off models. They'll fine-tune models, distill, train based on the models that are already available. So you end up with this very complex ecosystem that's only becoming more complex every day. As people figure out ways to get a slight performance edge over another, or which models are better at which specific thing. Something to mention at this point as well, because it will come up more and more when we're discussing efficiency and when to use large language model, when to use a small language model, is mixture of experts, which is a technique that combines specialized models using a gating network. The idea being that it appears to be a sort of combined model. So it might be packaged as a combined model by a developer, and it's available through the cloud. What happens when you're interacting with a mixture of experts model is, depending on the prompt you give it, it activates a specific smaller expert within the model that's good at that one thing. So you might see a list of the total parameter size for a mixture of experts model. It might be several billion parameters. It could be hundreds of billions of parameters, but only a set number of those will be active at any given time because it will depend on the input that's being given. Now, the benefit of that is it's much more efficient because it's not activating all the stuff that's really good about answering legal questions when what you've asked it is just an FAQ question. So you might get quicker response times depending on what you give it. The drawback of that, and I had some discussions about this at Google Cloud Next, is you need very elastic compute to meet those inference demands, because what you then have basically is a model where you're saying, I don't know how much compute this is going to need at any given time. It's entirely dependent on what the user asks of it. So it's much more efficient on paper, provided you have that really elastic compute and great infrastructure that can meet those demands. So you need great storage, great networking. It ends up being very complex at the construction phase.
At which point you might as well just put it in the cloud, surely, the public cloud. It is one of those things, like, kind of, it feels very much kind of like you're pulling something apart only to put it back together again in a possibly more expensive or less convenient way. The reality is, if you need the capability of one of the hyperscalers, you probably don't have the capability to do that yourself, or it wouldn't make any economic sense to do so. So, I mean, I'm left wondering whether this is a bit of either a dead end, or whether it shows that the way that we're going with generative AI being used for everything and anything, in some ways it actually shows its limits, because it can be, but ultimately, is that what you need? That's my feeling on it, that it's almost that it's starting to try to solve problems where it is actually not the best tool for the job. Something more specialized is.
Yeah, I think we're at this phase still. It feels like we've been saying this for a few years, but we are still kind of at a discovery phase where it benefits everyone to have all of these options on the table. So small language models are very useful for some use cases. It's very beneficial, especially that they are, by and large, open. So people can download them and deploy them in different ways. Some of them are open source as well. So that means you can really pull them apart, fine tune them, figure out how they work, and distill them for whatever purposes you're looking for. At the same time, there's no doubt, this is the argument, obviously, that Amazon and Google are making is, well, public cloud is still best. So when you're looking for this elastic compute, say for a mixture of experts model, yes, please don't try and build that in your backyard. The infrastructure already exists for this. You'd be maybe unwise to try and do that on your own. So I think it still feels like a kind of all of the above situation. You try out all of it and see what works best for your business. But yeah, I think there is a feeling that the AI developers would really love to be able to sell this as an all-in-one package down the line. I think the ultimate kind of goal that a lot of them are striving towards is beyond a mixture of experts. It's a model that would be able to intelligently use a portion of its parameters without needing that elastic compute, or a model that can solve some of these incredibly difficult problems and also respond at the speed that customers are looking for. It's just a technological problem right now. It's some of these networking capabilities that are limiting it, as well as demand. I mean, we're talking about that more and more, but the other benefit really with some of these small language models is they are just less energy intensive. And there is a hard limit on what even the hyperscalers can deliver in terms of demand. And you're seeing that in price as well. Take GPT 4.1 Nano. So as I mentioned earlier, OpenAI's smallest model, its cheapest model to inference through its API, that costs 10 cents per 1 million tokens of input in the cloud. Compare that to its largest model that's currently available, and it is being soon taken off the API and made unavailable to customers. And they were saying it's more of a potentially an experiment or a test. There is some feeling, unconfirmed, but some feeling that this is related to actually OpenAI struggling to meet demand. GPT 4.5 costs $75 per 1 million tokens input. It costs $150 per 1 million tokens of output. So there was already some indication there of the strain that it was putting on OpenAI, just in trying to control demand by making it so expensive to actually inference GPT 4.5. But these small language models, it's clear, allow for things to be more affordable for businesses, and also for the hyperscalers and the AI developers to actually run the models and meet demand.
Well, I guess as with all these things, we will see how useful they are or not as time goes on. And unfortunately, that's all we have time for today. But thank you for joining us.
As always, you can find links to all of the topics we've spoken about today in the show notes, and even more on our website at itpro.com.
You can also follow us on LinkedIn, as well as subscribe to our daily newsletter. Don't forget to subscribe to the IT Pro podcast wherever you find podcasts. And if you're enjoying the show, let us know by leaving a rating or a review.
We'll be back next week with more from the world of IT. But until then, goodbye.
Goodbye.